Okay, for this one it says, use the data in the table to the right to answer the following questions. We have a table that has the weights of a sample of bag of candy. We've got colors of candy. We have red with a certain number of weights. We have blue with a bunch of weights, brown, green, and yellow. And it reads, find the sample proportion of candy that are red. So we don't even need these weights, do we? It's not asking anything about the weights of the candy. Maybe it will in a subsequent lesson, but in this one, all we're wanting to know is what proportion of these candies are red. So we just count. How many red do we have? We have 1, 2, 3, 4, 5. So we have 5 red out of how many total candies do we have? And if you add them up, we have 10, 20, 30, 39, and 5 is 44. So 5 over 44, which is 0.114. So that's what you would put. The proportion of red candies is 0.114. And now it says, use the result to construct a 95% confidence interval estimate of the population percentage of candies that are red. Okay, so this is the point estimate. This is the p hat, 0.114. And again, I'm just going to use technology. I'm not going to build these by hand. You are welcome to. That's how all the view examples show them for some reason. That's why I'm doing these videos. So I'm going to go question help, and I'm just going to go to StatCrunch. I'm going to go to stat. Maybe you can't see that. Scroll down, stat. And this is a proportion, one sample. We do have the data, but I'm just going to do a summary. I've already counted them. Number of successes, we had 5 out of a total of 44. We're doing a confidence interval. It does say 95. If it ever doesn't say, just default to 95. They usually do say in these problems. And then press compute. And there's my interval. So there's my sample proportion. I already had 0.114. So the lower limit. Okay, I went ahead and put the statistics here so we can look at them. The lower limit is 0.02. Upper limit is 0.21. Now come up down here real quick. So this is where our students make a lot of mistakes. It already has the percent in. These are not percents. I got to convert those to percents. All right, so this 0.0198, that's not a percent. So I just have to shift the decimal point over a couple of places and round. So that 0.0198, that's going to be 0.02 or 2%. So that'd be 2.0%. And then the P, the upper bound is 20.7%, right? All I'm doing, again, is shifting the decimal point over 2 places to the right. 20.7%. And so that's what I put in. I hope that helps. There is a third part. I'm going to let, again, you think about that third part. The third part reads, is the result consistent with a 34% rate that is reported by the candy maker? So the candy maker says that 34% of these candies are red. This looks like a bag of M&Ms, doesn't it? So the candy maker says 34%. You've taken a sample of 44 and discovered that your sample was 11.4%, but we know there can be some sampling error, right? And when we crunch that out, we get that sampling confidence interval to be between 2% and 20.7%. So 95%, there's 95% chance that my interval contains the true population mean. So are we okay with that? Is the result consistent with 34% rate that is reported by the candy maker? I'm just going to go and tell you. Think about it for a second before I tell you. No. Right? The 34% is not included in my interval. Right? So they're saying 34%. You're saying it's very unlikely that would be more than 20.7%, right? So it's somewhere in this interval. So this is leading us up to hypothesis testing, but it's always good to think about this now. And we'll formalize that in the next chapter.